So let's start off by looking here. Here is just the constants. I set the seg list to 20, which is the number of segregated lists I'm using. And the following are a bunch of helper functions. So as the first one is already implemented for us, so let's move on to this part. So in this part, I define the main struct. It's called the MML node, and which stands for the memory management linked list node, and it represents a node in the free list. So each node stores the size of the block and a pointer to the next node in the list. And the global variables here include the head, which starts our free list, and the seg list head here. It's just array of pointers to the heads of each segregated list. And let's move on to this part. Um, this is another helper function I defined. So it can determine the index for the segregated list. It takes the size and returns the corresponding index for the appropriate segregated list. And I breaking up the sizes into 20. So and I think it really helps me to increase the throughput of the whole process. And let's move on to these two functions, the add to seg list and remove from seg list. So I think they're relatively simple because this function is just add a block to the segregated list, and this function is just remove a block from the segregated list. So in this function, I will check if the node is the head of the list. So otherwise, if not, I will just iterate through the list to find the block and remove the block. And here is another like a helper function I defined. I think this is pretty important because um, in this function I set up a threshold. So um, I decide between the first fit strategy and the best fit strategy based on this. So um, for the smaller requests, I will use the first fit. You can see it here. And for the larger blocks, I will use best fit. I think this strategy I can actually like improve the like speed the things up and reduce the fragmentation. So let's move on to the required functions. So here is just um, the initialization function. So it initializes the allocator, and I set up the start of my linked list and initialize the segregated list has to null. So yes, I think it's pretty simple. And let's move on to this malloc function. So it will first align the requested site and then align the size and then call the find fit function to check for a feed block. If it can find one, it just use it. So if not, it will extend the heap using this mem_sbrk. And then if a block has like the spare space, like excess space, it splits the block and adds the extra part back to the free list. So I've set this up to keep the fragmentation low, hopefully, and improve the memory utilization. And here is my free function. I think it is pretty simple because I didn't add any correlating strategies here. I tried to add them, but I cannot pass the test, so I just simply delete them. So here is the realloc function. It will or it handles three cases. So if the old pointer is null, I treat it like a new malloc call. If size is zero, I just free the old pointer, and if the current block size is large enough, I keep the existing pointer, and otherwise I just allocate a new block and using this memcopy to copy the data and then free the old pointer. And this is a predefined function, so let's move on. Oh, so here is my like the debug function, because it's designed to verify the integrity of my heap. So for each segregated list, I want to ensure that each free block is marked as free and it falls within the heap bounds. So I think that's all for my code. Um, I didn't get full points. I only got 70 on the final, but I think this project really helped me to understand the process of memory management and really pushed my understanding of the C programming. So I think that's all. So thanks for watching.